In today's lesson, we'll go over how to balance chemical reactions with some step-by-step examples. To begin, let's define what it means to balance a chemical equation. In a balanced equation, the number of each type of atom on the reactant side equals the number on the product side. This respects the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. Balancing ensures that each atom that goes into a reaction also comes out. Now, let's go over the steps for balancing a chemical equation. We'll walk through each of them, then look at examples to reinforce these concepts. Step 1 would be to write the unbalanced equation. First, we want to write out the equation with the reactants on the left and the products on the right. Step 2 is we want to count the atoms of each element. So we want to count the number of atoms for each element on both sides of the equation. Step 3 is to balance each element one at a time. Start with elements that only appear in one compound on each side of the equation. Adjust the coefficients to balance the atoms. Remember, you can only change the coefficients, not the subscripts, because changing the subscripts will alter the compound itself. Step 4 is to check your work or to verify your answer. Verify that all the atoms are balanced on both sides of the equation and that the coefficients are in the simplest whole number ratio. Let's look at an example. The first one is to balance hydrogen and oxygen in the formation of water. Our unbalanced equation is H2 plus O2 yields H2O. Counting the atoms, we see that there are 2 hydrogen atoms on the left and 2 on the right. However, there are 2 oxygen atoms on the left but only 1 on the right. To balance the oxygen atoms, we have to place a coefficient of 2 in front of H2O. Now, there are 4 hydrogen atoms on the right side, so we have to add a coefficient of 2 in front of H2. Now both sides have 4 hydrogen atoms and 2 oxygen atoms, so the equation is balanced. Let's work through a slightly more complex example involving polyatomic ions, where aluminum nitrate reacts with sodium sulfate to form aluminum sulfate and sodium nitrate. Here is our unbalanced equation. AlNO3 plus Na2SO4 yields Al2SO4 plus NaNO3. As a reminder, we'll balance each element or polyatomic ion step by step. So the first step is to count the atoms. Let's count the atoms or polyatomic ions on each side of the equation. For aluminum, we have 1 on the left and 2 on the right. For nitrate, which is NO3, we have 3 on the left and 1 on the right. For sodium, we have 2 on the left and 1 on the right. And for sulfate, which is SO4, we have 1 on the left and 3 on the right. Since we have polyatomic ions that remain intact on both sides, like the NO3 and SO4, we'll balance them as whole units. Step 2 is to start with the aluminum. So we see that there's a difference of 1 atom of the aluminum on the left and 2 on the right. To balance aluminum, we have to place a coefficient of 2 in front of AlNO3 3. Now, we have 2 aluminum atoms on each side, but this also affects the nitrate ions. Now on the left, we have 6 nitrate ions. Again, nitrate is the NO3. Step 3 would be to balance the sodium and the nitrate. So let's do that. On the left, we have 2 sodium atoms, but only 1 on the right. And we only have 1 in NaNO3. To fix this, we place a coefficient of 6 in front of NaNO3 and a 3 in front of the Na2SO4. Now we have balanced both sodium and nitrate. Each side has 6 Na atoms and 6 NO3 ions. Step 4 would be to balance the sulfate. On the left, we have 3 sulfate ions, and on the right, we also have 3 sulfate ions. So all of the atoms, or polyatomic ions, are balanced, with each element matching both sides of the equation. For a third equation, I want you to try it on your own and pause the video and come back when you have an answer. This is a combustion reaction of propane with oxygen to produce carbon dioxide and water. Our unbalanced equation is C3H8 plus O2 yields CO2 and H2O. Again, step 1 would be to count the atoms. We have 3 carbon on the left and 1 on the right. We have 8 hydrogen on the left and 2 on the right. And finally, we have 2 oxygen on the left and 3 on the right. The next step would be to start by balancing the carbon. There are 3 carbons in C3H8 on the left, so we can place a 3 in front of CO2 to balance it. Next, let's look at the hydrogen. There are 8 hydrogens on the left, so we place a 4 in front of H2O to also have 8 hydrogens on the right. Now, let's balance oxygen. On the right, we have 7 oxygens. We got the additional 4 from putting the coefficient of 3 in front of the CO2. Putting the coefficient of 4 in front of H2O gives us an additional 3 oxygen atoms, totaling 10 oxygens. To balance this, we place a 5 in front of the O2 on the left side. Now the equation is balanced. For our final example, I want you to try to pause the video again and solve this on your own. We're going to be balancing a decomposition reaction where potassium chlorate decomposes into potassium chloride and oxygen. The equation for this, the unbalanced equation, is KClO3 yields KCl plus O2. Again, step 1 is going to be to count the atoms that we have right now. Potassium has 1 on the left and 1 on the right. Chlorine has 1 on the left and 1 on the right. Oxygen has 3 on the left and 2 on the right. So we need to balance the oxygen. We need the total number of oxygen atoms to be the same on both sides. We can place a coefficient of 2 in front of the KClO3 and a coefficient of 3 in front of the O2 to get an even number of oxygens. But then we need to put a 2 in front of the KCl to balance the other elements. Now each side has 2 potassium atoms, 2 chlorine atoms, and 6 oxygen atoms. The decomposition reaction is now balanced. To recap, the key steps to balancing chemical equations is to first write the unbalanced equations and list all the reactants and products. Step 2 would be to count the atoms of each element. Identify atom counts for each element on both the product and the reactant side. The third step is to balance one element at a time, adjusting only the coefficients. Remember to never change the subscripts. And step 4 would be to verify. Ensure equal atom counts for each element on both sides and use the simplest whole number coefficients. In this video, we used the 4 following examples to highlight how to balance these chemical reactions. With practice, balancing chemical equations becomes straightforward. Just remember to start with individual elements or polyatomic ions, use coefficients to adjust the atom counts, and verify each element at the end. Thanks for watching.